Hello guys, welcome back to Ed's tutorial video on Arduino project. In case you haven't done so, kindly subscribe to my channel, like the videos, drop a comment, and don't forget to turn on your notification bell so you get to be notified whenever we drop a new video. Okay, in our last video, we did the rudiment of Arduino's project, which is turning on and off of LED lights using Arduino. Okay, that is like the hello world of Arduino's project. Okay, we call that blinking LED. Okay, and we're going to use that as a foundation for today's project. And today we are going to incorporate push buttons to our project. Okay, we're going to learn how to use push buttons to turn on and turn off our LED. Okay, and to do that we need our breadboard, our Arduino Uno. You can also use any of the Arduino Nano as well if you have that. Our push button, our LED, can use red, can use green, can use blue, and we have two current limiting resistors. The first one is 10 kilo ohms resistor, while the second one is 330, or you can use 220 ohms resistor, but here I'm using a 330 ohms resistor. Okay, now before we continue, I would like to quickly run through the concept of these push buttons. Okay, I would like to run through the concept of push button and see how it works. Now remember, we're using a pull up and a pull down resistor. Okay, so I'll run through the concept of push buttons using pull up and pull down resistor. Now I believe while you were in your science class, you probably have done a switch. Probably have done switch as a in your subject, in your class rather, and a switch symbol is represented using this, right? This represents an open switch. Then if you have it this way, we call it a closed switch. I believe you can remember this. Okay, so now our push button basically operates with the same principle. Okay, the push button operates with the same, or using the same principle. Okay, so now let's have this diagram of the push button here. So this is a push button. Now, by the way, you can see this push button appears to have 4 legs or 4 pins, right? Which is rightly so. But however, these 2 pins are the same. They are connected to each other, so they're basically the same thing. And also, the 2 pins as well here are also the same. So, based on this project, we are going to use these 2 pins. These 2 are the ones we're going to use for the project. These are the 2 separate pins that we're going to use for the project. Okay, or these 2 as well. Okay, so if you have okay, let me just bring it up to the side and clean this. A push button, okay, and this unshaded circle means that it is open, so it's going to look like this. Okay, so this is an open push button. Okay, and if you have it this way, if you have a shaded button, a shaded circle rather, this shows it's a close push button, so it's going to appear like this. Close. This is close, while this is open. Okay, now if one leg of this resistor, also of this push button, is connected to a 10 kilo ohms resistor, 10 kilo ohms resistor, right? 10 kilo ohms resistor, and this end is then connected to a 5 volts. Now, where does this 5 volts come from? The 5 volts comes from the 5-volt pin of the Arduino. Okay, the 5-volt pin of the Arduino, which means one leg of the resistor is connected to the one leg of the pin of the switch or the push button, while the second leg of the resistor is connected to 5-volt pin of the Arduino. Okay, then the other leg of the push button is then connected to the ground, the G and D. That is the ground of the Arduino. I hope you can see what I'm writing. The ground of Arduino is here. Okay, all right, so the ground, the other leg is connected to the ground of the Arduino. Now when this happens, okay, also we're going to have a read pin at this point here. This point is connected to the read pin of the Arduino, the RP. Now the read pin of the Arduino are these pins that are 1 to 13. You can use any of them. So these are basically the read pin of the Arduino. Okay, so we have a connection from this resistor here that is attached to the one leg of the push button. Then is connected to the read pin of the Arduino. Now what happens is this: once these 5 volts pass through this resistor, since this push button is an open push button, right? What happens is that the read pin will be able to read this voltage that is passing through this resistor. And when it happens, when that happens, the Arduino will see it as 1. To see it will read it as 1. It will display as 1 on the serial monitor. Okay, it will display it as 1 on the serial monitor. Just give me a minute. Let me adjust this a bit. Okay. All right. And on this other side, if you have a closed push button, the same setup, we have a resistor attached to this end. Okay, 10 kilo ohm resistor. And the end of the resistor is connected to 5 volts of the Arduino. All right. And the other leg of the push button is connected to the ground of the Arduino, G and D. Now, what happens is this: since it is closed, these 5 volts will be able to pass through this resistor. Then also, don't forget our RP, our read pin. You connect our read pin from here, the RP of the Arduino. Okay. Now, once this 5 volts pass through this resistor, because it is closed, it will be able to pass and go to the ground. So the voltage or the current will be able to pass through and go to the ground. In that case, the Arduino will display it as 0. It will display it as 0 on the serial monitor. Okay, now this is called a pull up. Okay, now a pull down basically is just like the opposite of a pull up. Okay, now this will happen in a pull down. This is what happen in a pull down. The setup is this way. Now in a pull down, let's say we have our switch, our push button here. Sorry, you have a push button here. Okay, and it's open, right? So we have this and we have this. Okay, And so in a pull down, this part of the push button is connected directly to 5 volts. Okay, while the other leg is then connected to the 10 kilo ohms resistor, which is then connected to the ground of the Arduino, GND. Okay, and our RP is also on this part. We are going to read from this point. RP, that is the pin on the Arduino, right? Then this is the open part. Then the closed part, let's say we have a push button and we have closed. The shaded circle shows that it's closed. Then we're going to have this connection like this, right? And this part of the push button, the push button is connected directly to 5 volts, right? And this part is then connected to 10 kilo ohms, 10 kilo ohms, 10 kilo ohms, rather, kilo ohms, okay, which is then connected to the ground of the Arduino, G and D. Now let's see what happened here in the open part of the push down. This is the open and this is the close. Now in the open part of the push down, since there is it's open, right? So once current or voltage pass through this, because it's open, the voltage will not be able to pass through, right? So the read pin will then see it as what? As 0, which will be displayed as 0 on the serial monitor. Okay, then on this other one that is closed, because it is closed, the voltage or the current will be able to pass through, and the read pin from here, RP, will be read, and it will see it as what? As to display it as 1 on the serial monitor. Now the reason why it's displayed as 1 is 0 and 1 is because it's a digital read, and in digital it's either it is 0, it's 0 or it is 1. Either it's 0 or it's 1. Let me write so here. It's either it's 0 or it is 1. It can't read in between. Okay, it can't in between. So that's why even though it's 5 volts, whether it's 5 volts or 3 volts or 2 volts that it's passing through, the Arduino, the computer, will see it as what? Read as 1, because it's digital. Okay, so that is the concept of a pull up and a pull down. This one is a pull down. The first one was pull up, and this one is a pull down. So basically this is the concept of the pull up and push and pull down resistor, okay, using a push button. All right, so now let us go straight to connecting our component. Okay, so here we have our breadboard. All right, the first thing we're going to do is to connect our push button. Connect our push button. Okay, we're going to connect it this way. These are the two parts, the two pins we are using, right? Don't forget we are using this one and this. We are not using this and this. Okay, so we connect this way. The first two parts of the push button is connected to the first half of the board, and the second two parts, the second two pins are connected to the second part of the board. So we have it this way. Don't forget you can place it anywhere. It doesn't have to be exactly where I placed mine. Okay, now we are going to we are trying to set up a pull up. Okay, we're trying to set up a pull up, and let me show you the diagram of a pull up again. Okay, so a pull up. Now firstly, we have connected our push button. The next thing we're going to do is to connect our 10 kilo ohms resistor. We have our 10 kilo ohms resistor. we connect one end of the resistor to one end of the push button pin. Okay, as you can see here, this is the pin. Now if you can remember from my first video, I explained the concept of the connection of breadboard. So this part, the middle parts, they are all connected vertically. Okay, so if you have our breadboard, our pin here, our push button pin here, it means that all these ones too are connected to the push button pin. So you're not seeing what I'm doing. Okay, if you have a push button pin here, it means all this, sorry, it means all this part, just give me a minute. Okay, so it means all the, if you have a push button pin here, it means all these parts, all these pins are also connected to this push button. So we put one leg of the resistor in one of these, in that pin, one of the holes there, and then the other leg of resistor, we can put it anywhere like this. Okay, all right, then one end of this, this end of this resistor is then connected to the 5V of the Arduino. So we connect it this way, the 5V. If you look here properly, the 5V is right after the GND, after the ground. Okay, this is the 5V. All right, then what else? The second leg of the push button is then connected to the ground. Now we are going to use this straight line, these pins on this blue line, as our ground. Now the connection here is that all the pins horizontally on this side are connected to each other. So all the pins on this blue line are connected to each other, and also this red line, all the pins are connected horizontally. Okay, but they are not connected vertically. But on this side, on the middle part here, they are all connected vertically. All right, so we are going to use these pins here close to the blue line as our ground. So we connect one leg of the other leg of the push button to this blue pin close to the blue line. Then we ground it by connecting any point of the blue line to the ground of the Arduino. Okay, to the ground of the Arduino. By doing that, we have grounded all the lines, all the pins on the blue line, which also has grounded the second leg of the push button. Okay, now what is the next thing to do? The next thing to do is to read the value, the RP, and the read we are reading from this leg of the push button that has the resistor, and we connect it to any of the pins on the Arduino here, the RP. We're using, let's use pin 2. Let's use pin 2. You can use any pin you want. Okay, but we are using pin 2. So now our setup is complete. The next thing to do is to open our Arduino IDE and run the code that will tell our push button what to do, that will tell our setup what to do, and we'll be able to monitor, see from the cell monitor if our push button is working or not. Okay, so now we're going to connect our Arduino to a computer. We connect our Arduino to the computer. As you can see, it's on, so which means it has been connected. Then we open our Arduino IDE. Now, in case you haven't done that, go to Arduino website. You download the IDE. That is where you'll be able to run the code of the program. Okay, so now let's open our IDE. Okay, so this is our Arduino IDE, and for the sake of time, I am going to put the code here, but I'll ensure that I explain what the code is all about. Okay, so I'm going to paste the code here, and okay, this is the code. For now, we are going to leave this. We're going to remove this part of the code. We'll come back to it later. This part of the code. Okay, we'll move this. We'll come back to this later. Okay, so this is the code. Now, this code is we're going to use this code to see if our push button is actually working fine. Okay, before we continue with the rest of the project. So now, once you've done that, once you have put the code, and just upload the code using this button here, using this this here, click on this, and it will run the code. Now, if there's an error, it will be displayed, and it will tell you what is wrong with the code. Okay, but if there is no error, it will upload successfully. Now, let's see what happens here. It appears that we have an error here. It says we need a curly bracket. This curly bracket at the end of input, so which means at the end of everything, we're supposed to have a curly bracket here. So that's why our code did not upload successfully. So let's put a curly bracket there. Curly bracket. On this should be the closed one. Okay, so we have put the closed curly bracket. Now let's run it again. Let's upload it again and see what happens. Boom. Now it's done uploading. Okay, now let me before we continue, let me explain the code here. So basically what we did is, the first thing to do is to put in your variables. Okay, and our first variable is our button pin. The constant integer, const int, that is constant integer, button pin equals to 2, which means our button pin, remember we put our button pin, we connect our RP to pin 2, so that is the 2 here. And don't forget your pin, P should be in capital, and also don't forget to put your semicolon. Our next variable is the LED pin. Now, for now, we're not using this LED pin, but we're going to use that later. But let's just leave for now. We're using pin 8 as our LED for our LED pin. Okay, so that's our second variable, constant integer, LED pin equals to 8. Don't forget the semicolon. Then the integer button rate. Then we put write down our variable for the button rate. Like, what do you want the buttons to do? That's what this integer button rate means. Okay, so the variable for button status. Once you press the button, what will happen? Okay. Then the next one is the constant integer, that's delay time, DT. Okay, I'm using 250. You can use any value for your delay time. You can use 100, you can use 200. Okay, that is once you press the button and you remove your finger from the button, the delay time before the LED turns off. Okay, then the setup. Let's look at the setup. Now this setup, we are using remember we are using a serial monitor. Okay, so to use a serial monitor, we have to write out this code, serial.begin. Now this 115200 is like a channel at which the serial monitor will appear. Okay, we have different channels. We have different number of different channels actually. Okay, I'll explain that later on. Okay, so but in this we are using this particular channel 115200. If you're using 9600, you have to make sure that you put 9600 on this code here, and make sure that your monitor is also tuned into channel 9600. Okay, then the pin mode, LED pin is our output. Then the second pin mode, the button pin, is our input. All right, and don't forget to put your output and input should be in all cap and your semicolon. Okay, then also don't forget the close curly bracket. Then our loop basically is what we want this to do. You want it to what? To read the button state. Okay, you want it to read the button state, if the button state is closed or not. And if that happens, it will display it will print it out as serial.print, okay, on the serial monitor. So basically that's what the code is all about. Now we have run it, we have uploaded it already. So let's open our serial monitor and see what's happening. Let's open our serial monitor, go to this part of the ID of the sketchbook and click on serial monitor. Now as you can see, the serial monitor is showing 1 1 1 1 1, which means it's open for a pull-up resistor. Remember we said in a pull-up resistor, if it's open, it's going to display 1 because it's open, the current is not flowing down to the ground. All right, now let's see what happens if you press the push button, which means once you close the push button, let's see, you want to see what will happen. So once you press the push button, let's see what happened to, okay, once you press the push button, let's see what happened, what will be displayed on our serial monitor. Let's see our serial monitor. Now I'm going to press it now. I hope you hear the click sound. And let's see what it's displaying. As you can see, it's displaying 0, which means the current has been able to flow through the ground, and the read pin is reading it as 0. Okay, and that's why it's displaying 0 on the serial monitor. Okay, and if I remove my finger, it goes back to 1, which is open. Okay, all right, so now, which means our setup, our push button setup is complete. Now let's incorporate our LED to this setup, so in a way that once you press the push button, it turns on the LED. Okay, so that's where the second part of the code will come in. Okay, so for the sake of time, I've already written out the code, and I'm going to put that now so we can see the code. Okay, so I'm just going to paste the code here. No, just give me a minute. Okay, I'll paste the code here. Then we'll see what happened. Okay. But rather, before we continue with the code, we'll have to set up our LED. First, we have to set up our LED to our connection. Okay, we have to set up our LED to our connection before we continue with the code. All right, now these are LED. These are LED. In my previous video, I explained the LEDs. You have two legs. The longer leg, which is the anode, and it's positive. And the shorter leg, the longer leg is anode positive, the shorter leg is cathode, which is negative. Okay, so just place the LED on the on any point of the bread on the breadboard. Okay, now the longer leg, which is anode, is facing the right side, while the shorter leg is on the left side. Okay, so let's place it this way. Now we take our 330 ohms current limited resistor, or you can use 220 if you have 220. Okay, so where is it? This is not it. Where is our, okay, here it is. Okay, so this is our 330 ohms resistor. All right, so you place it, one of the leg on one of the pin close to the shorter leg of the LED. Okay, and this other leg is then grounded, so we can place it directly to the ground. Now remember this, all this blue line has been grounded. Now you can place it to the ground here. You can place it to the ground here. Okay, but I have a theory. I think the distance between this ground here and this ground here, I think they are I'm not sure this from this side, from this half of this board, I'm not sure this ground here is properly connected with this side of the ground. Okay, I don't know if it's on my board or if that's how it is done. So what I'm going to do to ensure that these parts, all these parts are evenly grounded, I will connect from here, from this end, okay, to this end. Okay, I'll connect the ground from this end to this end. Now that will ensure that all the pins on this side they're also grounded. Okay, now the other leg of the LED is then connected to the pin. And what pin did we see before in our code? The LED is connected to pin 8. We use pin 8 in our code, so we connect it to pin 8 of the Arduino. So this is our Arduino connected to pin 8 of the Arduino. Okay, all right, so now we are done with this setup. So let's go back to our code and upload the one that have the LED, and let's see what happened there. So in this code, what happened is this: we include what they call an if statement. An if statement is probably what tells the Arduino what to do once the push button is pressed on. Okay, so you can see here from the if button read equals to 1. Okay, the digitalRead LED pin low, which means that if the button read is equal to 1, the LED pin will be low, and low means what? Off. Okay, low means off. And if the button read 0, that is on this monitor, if it reads 0, which means digitalRead LED pin is high, and high means on. So this is just the if statement which we have included to the code, to the previous one we did before. Okay, and that will be able to help us to turn on and off the LED. So let's upload. So we're going to upload now. Okay, done uploading. Okay, now let's press our let's open our serial monitor. Open the serial monitor. Okay, now as you can see, the serial monitor is showing 1, and 1 means low, and that's why the LED is not on. That's why the LED is off, as you can see, because the serial monitor is reading 1, and 1 means low, which is off. Now let's press the push button. Okay, and if you press the push button, the serial monitor becomes what? 0, right? As you can see, 0, and 0 means high, and high means what? On. So let's also look at our LED and see what happens to our LED. Boom, you can see our LED is on. If I remove my hand from the push button, it turns back to 1, and which is off. As you can see, press it again, on. You can see the delay time. That is what the delay time is all about. Okay, on, off. Okay, ladies and gentlemen, that is how to incorporate push buttons into the project. Okay, you're able to use that to close, to on and off LEDs. You can also use to do any other project. It could be your servo, it could be your motor, It could be to open doors, to close doors, open windows and close windows. Okay, it opens door to so many possibilities. Okay, thank you so much for joining us today, and don't forget, once again, kindly subscribe to our channel, like the video, drop a comment, and don't forget to turn on your bell notification so you get to be notified whenever we drop a new video. Okay, so in our next video, we're going to be looking at some other application of this push button, and I would like you also to try it at home. Probably try and play around with this particular project and see what you can do once you press the button. Like, to press the button, once you press the button on, once you press the button once, it will on, and if you press it again, it will off. Okay, so that's what we are going to do in our next project. This particular project, right, if I press it once, I have to hold it before it's on, right? If I leave it, it's off. So in our next project, we are going to look at, once you press it once, it on, and if you press it again, it's off. Okay, it's switched off. Okay, so that's what we're going to be doing. We're going to look at in our next project, in our next video. Okay, and thank you for tuning in today. See you some other time.